We are going to start with neural networks at the beginning, and then we will explore different components of this neural network. So we are going to learn about different parts, components, concepts which are necessary in order to create a neural network. Now we'll discuss about the most important topic, that is neural networks. So what are neural networks? Neural netro- Neural networks are like brain neurons, each neuron connected to every other neuron, which has the capability to understand and solve complex patterns. Now, neural network, as we know that in human being, we can sense all set of information which is happening around us due to the sensory organs, as well as there is a complex architecture of neurons within this body which is connected to the sensory organs. So we can sense something and the neurons are passing the signal to the brain. And due to that, the brain is able to compute or understand or process that information. So here also neural networks are like brain neurons itself, which are actually connected to each and every which are actually connected to other neuron, and the process is to the task is to process the information and pass the information to the brain, and that's how it is able to understand complex information which it is perceiving. Now we will try to understand how neural networks are actually there. So neural networks are the heart of everyday technology, like we are using it almost everywhere. Like if you want to understand that, we have automatic car plate recognition system where it can automatically recognize what is the number plate of car. If you want to decode handwriting, we have applications. If you write something, it will automatically detect what it is written. So if you want to detect the handwriting on postcodes or somewhere, if you are writing, so we can implement this neural networks to recognize the patterns of handwriting. There are programs that employ neural network are also capable of learning on their own and adapting to change the conditions. So there is a huge application of neural networks, and the way we have combined the hardware and software along with the mathematics which was done in the past, we are capable of now doing things which are kind of imaginary in the past. Now how does this emerged? So image recognition requires human intelligence, something that machines lack, however complex and powerful. So if we talk about recognizing images, machine it is difficult. Machine can store the images, but it will not tell you what is that image. And it is complex because images are not at all going to be stationary all the time. It keeps on evolving, so it requires humans perceptions of understanding what is there in that image. Now if you want the computer to get better in solving this kind of problems, as they are fast and we want them to do, because as they don't get tired, because machines can do a lot of processing easily without getting tired. If I ask someone to process 10,000 images and label what is there in each image, for a person it will be difficult because he will not be able to like match up the speed, or he may get tired, and even he may lose interest over the time, and there is a possibility of error as well. But when it comes to machine will do it like in a blink of a seconds. Now the problem of complex uh, the artificial intelligence, like what is artificial intelligence? So artificial intelligence is all about problem, computer and human. Problem is complex mathematical operations, and if you want to talk about image recognition as an example of it, then computer for a computer it is easy to do complex mathematical operations. Compared to humans, human will find it hard. When it comes to image recognition, machine will find it hard or computer will find it hard, but humans will find it easy. So the problem here is complex mathematic calculation cannot be done by a human being easily, but a machine can do, and image recognition can be done easily by a machine, by a human being, but not by a machine. It will find it hard. So we want these two kind of like we want the machine to get this ability of understanding the images. So here we'll try to understand how a human brain learns. So you can see the structure over here. In this structure you can see there are dendrites, synapses. These structures are dendrites, synapse. You can see here we have a synapses, we have axons, and we have nucleus in a human neural cell body. So if we talk about a human neuron, it has all these structures, primarily this nucleus, dendrites, axons, and synapses. Now these entire structure is something which will help to process information from surrounding in a human body. Like human body conducts the information due to this neural cell body. Now if we talk about a neural network, we have in a neuron, in a human neuron, the collection of signals from other structures or other environment is done by dendrites. Okay, dendrites will collect information. The neuron basically sends out spike of electrical activity through a long thin strand known as axon. So axon is something which will pass the electrical signal, because see, the information that we are talking about is not in a physical form, it is in a form of electrical signal. So the information is passed through this axon into thousands of branches of other neurons. Okay, and at the end of each branch, a structure called as synapse converts the activity from the axons into electrical effects that inhibit or excite activity in the connected neuron. So that we have synapses which helps to convert the activity of the axon into electrical effects. So whatever is the information, synapse will help you to convert that information and send it to the next processing neuron. So these are the three components which are important in a human neural network or human body, which helps us to process the information. Now we will try to compare or create a neuron which is similar to human neuron. Okay, so if we talk about biological neuron, we have this axon, we have this nucleus, and we have dendrites. These are the three important components which actually engage in getting some information from the surrounding, processing the information in the nucleus, and passing it on to the next neuron through axons. So let's talk about the similar thing in an artificial neural network. Now, what is an artificial neural network? Artificial neural network is something where we will take the information from the surrounding and we will process the information, and then we will create a output. This is what we are doing in a biological neuron. So artificial neural network takes the information like this from surrounding and it processes in this neuron. We call it as a neuron. This is an input layer. This is a neuron in which the information is processed, and after processing the information, an output is generated which will go out. Okay, so this is how we can kind of map how a biological neuron can be mimicked using a machine and create an artificial neuron. It is very much obvious that we cannot have the same level of processing that a biological neuron is going to have, but we are able to do the perceiving of information to a level that we can have similar functionality that a biological neuron has through a artificial neuron. So uh, the efficiency and everything of biological neuron, no doubt it is going to be high, but artificial neuron does similar kind of activity, and it eases out the way humans are doing things. So basically both the things will do similar activities on a scale. Now let's talk about perceptron. So the simplest and oldest model of an ANN is called perceptron. So perceptron is a linear classifier used for binary prediction, that is supervised learning, and this means that in order for it to work, the data must be linearly separable. However, most of the real life problems are not going to be linear in nature, and when it comes to model a very complex non-linear boundary multi-layer neural network basically helps us out. Okay, so perceptron is a linear separator. A single unit of neuron that we have seen is a perceptron. So perceptron is a single unit, and it is kind of linearly separable in nature. And what is linear separation basically, which means we have a clear indication of something, dividing the data into multiple parts. So if we talk about this, linear separation is all about clearly having a clear division between the data. So perceptron learning rules state that the algorithm would automatically learn the optimal weight coefficients, and the input features are then multiplied with this weights to determine if a neuron fires or not. So basically perceptron is a single neuron which takes information from the surrounding, and there are certain weights which are initially initialized, and it automatically adjusts the weight based on the activation function and the optimization done, and it improvises the weights based on the error which is passing over. So basically, as I discussed, the neural network has a mechanism of feedback where it improvises the learning based on feedback. So error basically helps us to adjust the weights. So let us understand what is a simple neuron. So a perceptron is artificial neuron with many inputs and one output, and this perceptron is the structural building block of any deep learning network. So it has two modes of operation basically, training mode and using mode. Neuron is trained for multiple particular data or patterns into the data where it will learn something, and second is using mode, where when a taught input pattern is detected, its associated output becomes the current output. So basically neuron has two mechanisms over here. If you see the structure, this is the input mechanism where it will perceive some information from the input or the surrounding. It learns that information and it processes that information based on a certain formula which we are passing in the neuron, and it will generate an output. Okay, it will generate the output, and based on that output, the dependence of like how the data is actually dependent over each other, or how the associated of this data is based on the output data is actually learned.